Okay, in 7.8, we're going to factor what we called x squared plus bx plus c. But first I need to show you what x squared plus bx plus c is and what factoring means. So you don't need to copy these two, but I'm going to use those to demonstrate what factoring is and what x squared plus bx plus c. Okay, I'm going to multiply them out. We've learned two methods for multiplying. The first is to distribute the x, or use distribution, so x times 2. So x squared plus 2x. And then I distribute the 5, so plus 5x plus 5 times 2 is 10. And then I get for my final answer x squared plus 7x plus 10. That's when I multiply it out. I'm going to multiply out the next pair too, and then we're going to go back and look at the pattern. The other method we learned for multiplying is by making a little box. And I don't mind which way you use it at this point. Okay, so let's see. This is x minus 8 times x plus 3. X times x is x to the second. Minus 8 times x is minus 8x. Plus 3 times x is positive 3x. And 3 times negative 8 is negative 24. So if I was writing my answer, that would be x to the second. Let's see, negative 8x plus 3x is negative 5x minus 24. Okay, we're going to look at this. I'm going to tell you. When we go in the forward direction like we just did, we're multiplying. When we start with the answer as our problem and we go back, this is called factoring. Okay, so I start here. I put it back into this format. That's called factoring. Okay, and that's what we're going to start doing today. If you look at these answers I got, this is x squared plus 7x plus 10, which is an example of x squared plus bx plus c, where the first term is an x squared. Same here, x squared minus 5x minus 24. Okay, but the main point is to look for a pattern. So what is the pattern here? Okay, so if I look at the initial problem, if I was given this, I'm trying to figure out where these numbers came from. Where did I get the 5 and the 2? Well, I see a 10. I know that 5 times 2 is 10. And I see a 7. With a 5 and a 2, if I did 5 plus 2, I would get 7. So there is a pattern that I'm going to look for. I'm going to look at the other example we multiplied, and then we're going to try it for real. Okay, this is, if I started with this, I'm trying to figure out where did I get negative 8 and 3 from? And just like the previous one, if I do negative 8 times 3, I get the last term. If I do negative 8 plus 3, I get negative 5, and that's where the middle term was. Okay, so that's going to be the pattern we're going to look for. So for example 1, we're going to factor each trinomial. We're going to list the possible factors and their sums, and then we're going to get the nice little answer. So I have x squared plus 12x plus 20. I want to turn it in to something like this. Okay, to start off, because this is an x squared here, it must have been an x times an x. So I'm going to fill that in. Okay, the other thing I'm going to fill in, no, I won't. I'll leave the signs for later. Okay, so the first thing I do is I look at the last term. It's a 20. I want to list the factors of 20. So for example, 4 times 5 equals 20. 2 times 10 equals 20. What else? 20 times 1. Okay, so those are all three of the possibilities for the numbers I could put here and here. I could put 4 and 5, 2 and 10, or 20 and 1. Okay, now to check which one's right, I need to make sure they sum up or add to the middle term. In this case, the middle term is 12. Okay, so I'm going to find the sum of each of these. So if I do 4 plus 5, I get 9. 2 plus 10 is 12. 20 plus 1 is 21. Because I want this to equal to 12, then it must be that 2 and 10 were the correct numbers. Since it's a positive, everything's positive in here, I'm going to put a positive 2 and a positive 10 here. And then that would be my correct factors. If I wanted to check, I could multiply it out. We're not going to multiply it out today, but in the future, that's another method we could do. Okay, let's try the next one. Okay, let's see. X squared plus 7x plus 12. Okay, it tells me to factor it. So I'm going to put it in the two parentheses. Since the first term is an x squared, I could put x times x, and actually, since everything is positive, I could put positives here. Okay, I'm going to first check for factors that match the last term. So factors of 12. What could I do? 2 times 6. Let's see, 12 and 1, 3 and 4. Am I missing anything? Okay, so those are the three possibilities for what might go here. It might be 2, 6, 12, 1, 3, 4. Okay, now to check which one's right, I'm going to find the sum. And the sum needs to match my middle term. So if I add 2 and 6, I get 8. 12 plus 1 is 11. No, 13. 3 plus 4 is 7. I want to pick the one that adds up to positive 7. Let's see, that's this, which means the 3 and the 4 were the correct values. So I'm going to put 3 and 4. And which one I put in which spot doesn't matter. And again, if I multiplied it out, that's the one that would end up being matching the original problem. Okay, I keep going. I'm going to keep doing the same thing. Okay, let's see, x squared plus 6x plus 5. Let me start the factoring. Because it's x squared, I'm going to do x times x. Since it's all positives, I can put the positive signs in. Although I will stop giving you all positives soon because that's boring. Okay, so I'm going to look at the last term. I want factors of 5. 5 times 1. Is there anything else? That's it. Okay, what is the sum of 5 and 1? 5 plus 1 is 6. Is that what I wanted? That is what I wanted. So it must be that this one of these is a 5 and one of these is a 1. It doesn't matter which one's which, but that's the only combination that multiplies and adds. Actually, it's the only combination. Okay, now I'm going to start adding some negative signs. Okay, x squared minus 11x plus 18. I'm going to set up the parentheses. Since this is x squared, I am going to put x times x. Oh, let's see. There's a minus sign next, so I'm not going to put pluses here because I don't know what's about to happen. I do know at least there's a negative in here. Okay, but I'm still going to look for factors of 18. So let me see. What can I times to get 18? 2 times 9, 6 times 3, 18 times 1. Okay, now let me see. I want them to add up to 11. 2 plus 9 is 11. Okay, but I actually want this to add up to negative 11. So 2 and 9 are the right values. They do add up to 11, but I want them to add up to negative 11. So I'm going to make this a negative 2 and a negative 9. Negative 2 times negative 9 is still positive 18, but now they'll add up to negative 11. So I knew that 2 and 9 were the right numbers, but the sign was wrong, so I changed it to a minus minus. And again, it doesn't matter which number goes in which spot as long as the signs are correct. Okay, and actually this pattern for signs will always match. If it's a minus and a positive, it will be a minus and a minus. And when you get used to that, you can fill that in faster. Okay, let's keep going. Okay, let me see. Factor this out. X to the second is x times x. It will not always be like that, so pretty soon I'll change it. Since there's a minus there, there must be at least a minus in this problem. Okay, now the factors of 8 could be 4 times 2. It could be 8 times 1. If I check the sums, 4 plus 2 is 6, 8 plus 1 is 9. I wanted to add to a minus 6, so I am going to use 4 and 2, but I'm going to use minus 4 and minus 2. So it will add up to minus 6. And minus 4 times minus 2 still makes a positive 8, so it still works. Okay, continuing. X squared minus 4x plus 3. Okay, x to the second is x times x. Let's see, to get 3 times 1. Okay, if I sum 3 plus 1, I get 4. But I want it to be a minus 4. So I'm going to make it minus 3 minus 1. Okay, let's keep going. X squared plus 4x minus 21. Since it's x squared, it's x times x. Okay, now I'm making a negative 21 at the end. Okay, so the factors of negative 21. I have to be careful because I have to do a positive and a negative. So what could it be? It could be 7 times 3, but I have to make one of them negative. It could be 7 times negative 3. What else? 21 times negative 1. Negative 21 times 1. I can switch the negatives back and forth depending on what I want it to equal. Okay, now let me see. If I do negative 7 plus 3, I get negative 4, but I want positive 4. If I do 7 minus 3, I get positive 4. So that's actually going to be the winner right there. But if it tells you to calculate all of them, I would still calculate all of them. Okay, so what was it? A positive 7 and a minus 3. And it doesn't matter which one goes where, but it does matter that the positive is with the 7 and the minus is with the 3. X. Okay, negative 10. Let's see, I could do 5 times 2. I could switch the signs. I could do negative 10 times 1. Let me see if I got it yet. Sum. Negative 5 plus 2 is negative 3, which means that's probably the right one. I just have the wrong sign. Since this is a plus 3, it must be positive 5, negative 2, because that'll add up to positive 3. Okay, so positive 5, negative 2. Doesn't matter which one goes in which parenthesis, but it does matter that the signs are correct. Okay, couple more. Okay, x squared minus 6x minus 7. X squared, so x times x. Let's see, to get 7. 7 times negative 1, or negative 7 times 1. Which one adds up to negative 6? This is positive 6. This is negative 6. So this is my winner. So negative 7, positive 1. And again, the order doesn't matter, but the signs matter, that the minus is with the 7 and the plus is with the 1. Okay, let's do this one. X. Okay, the last term is a negative 30. Okay, so let's see, 6 times negative 5, 10 times negative 3, 15, negative 2, 30 times negative 1. What do these add up to? 1, 7, 13, 29. What do I want it to? Oh, I have a negative x here. So this is like a negative 1x. So I actually want it to be negative 1. This one is positive 1, which means the numbers are probably right, but the signs are wrong. So let me try negative 6, positive 5. Negative 6 plus 5 is negative 1. So negative 6, positive 5 is the combination that works. Okay, after all that, what is the point of this? Well, one day we're going to solve equations that look like this. Actually, today we're going to solve an equation that looks like this. It's equal to 0 and it's in standard form. I want to solve it using the zero product property. The zero product property only works when it's in factored form. So I have to factor this. Okay, because the first term is x squared, I'm going to do x times x. Okay, it doesn't tell me I have to list out all the sums and products and the factors, but I still kind of need to think about it. So what can I times to get 15? 5 times 3, 15 times 1. Now I need to check which one adds up to positive 8. 5 plus 3 is 8. Okay, so it must be 5 and 3. I factored it, but it tells me to solve. So I'm going to solve using the zero product property, which remember says that if it's factored, either the first factor equals 0 or the second factor equals 0. And then I can solve this equation. Minus 3, x equals minus 3. Okay, so my solutions are negative 5 and negative 3. If I plugged negative 5 back into this equation and I substituted it in, it should equal to 0. It would be 25 minus 40 plus 15. That would equal 0. If I plug negative 3 in, to the x spots and evaluated this, this would also equal to 0, and they are the only two values that will work. Let's do one more like that. Okay, x squared minus 4x minus 12 equals 0. It's in standard form. I want to change it to factored form so I can do the zero product property. Because it's x squared, x times x. Let's see, what do I times to get negative 12? Well, negative 4 times 3. Does that add up to negative 4? No. How about negative 6 times 2? Negative 6 times 2, negative 6 plus 2 is negative 4. So it's negative 6, positive 2. And then I can use the zero product property to solve the equation. So x is 6 is one value that would satisfy the first equation. X equals negative 2 is the second value. And because this is degree 2, I got two answers.